So the indexing is fascinating. So is there something you could say about some interesting aspects of how the indexing is done?
Yeah, so indexing is, multiple parts. Obviously, you have to first build a um, crawler, which is like, Google has Google Bot, we have Perplexity Bot, Bing Bot, GPT Bot. There's like a bunch of bots that crawl the web.
How does Perplexity Bot work? Like, so that's a beautiful little creature. So it's crawling the web. Like, what are the decisions it's making as it's crawling the web?
Lots, like even deciding like what to put in the queue, which web pages, which domains, and how frequently all the domains need to get crawled. And it's not just about like knowing which URLs. It's just like deciding what URLs to crawl, but how you crawl them. You basically have to render headless render, and then websites are more modern these days. It's not just the HTML. There's a lot of JavaScript rendering. You have to decide like what's the real thing you want from a page, and obviously, uh, people have robots the text file, and there's like a politeness policy where you should respect the delay time so that you don't like overload their servers by continually crawling them. And then there's like stuff that they say is not supposed to be crawled and stuff that they allow to be crawled, and you have to respect that. And the bot needs to be aware of all these things and appropriately crawl stuff.
But most of the details of how a page works, especially with JavaScript, is not provided to the bot. Like, it has to figure all that out.
Yeah, it depends. If some publishers allow that so that they think it'll benefit their ranking more. Some publishers don't allow that, and you need to like keep track of all these things per domains and subdomains, and
Yeah, it's crazy.
and then you also need to decide the periodicity with which you recrawl, and you also need to decide what new pages to add to this queue based on like hyperlinks. So that's the crawling, and then there's a part of like fetching the content from each URL, and like once you did that through the headless render, you have to actually build an index now, and you have to reprocess, you have to post process all the content you fetched, which is the raw dump, into something that's ingestible for a ranking system. So that requires some machine learning, text extraction. Google has this whole system called Now Boost that extracts the relevant metadata and like relevant content from each raw URL content.
Is that a fully machine learning system? It's like embedding into some kind of vector space?
It's not purely vector space. It's not like once the content is fetched, there's some BERT model that runs on all of it and puts it into a big, gigantic vector database, which you retrieve from. It's not like that. Because packing all the knowledge about a web page into one vector space representation is very, very difficult. There's like, first of all, vector embeddings are not magically working for text. It's very hard to like understand what's a relevant document to a particular query. Should it be about the individual in the query, or should it be about the specific event in the query, or should it be at a deeper level about the meaning of that query, such that the same meaning applying to a different individual should also be retrieved? You can keep arguing, right? Like, what should a representation really capture? And it's very hard to make these vector embeddings have different dimensions, be disentangled from each other and capturing different semantics. So, what retrieval typically, this is the ranking part, by the way. There's the indexing part, assuming you have like a post-processed version per URL. And then there's a ranking part that, depending on the query you ask, fetches the relevant documents from the index and some kind of score. And that's where, like, when you have like billions of pages in your index and you only want the top K, you have to rely on approximate algorithms to get you the top K.
So that's the ranking, but you also, that step of converting a page into something that could be stored in a vector database, it just seems really difficult.
It doesn't always have to be stored entirely in vector databases. There are other data structures you can use.
Sure.
And other forms of traditional retrieval that you can use. There is an algorithm called BM25 precisely for this, which is a more sophisticated version of TF-IDF. TF-IDF is term frequency times inverse document frequency, a very old school information retrieval system that just works actually really well even today. And BM25 is a more sophisticated version of that. Is still beating most embeddings on ranking.
Wow.
Like when OpenAI released their embeddings, there was some controversy around it because it wasn't even beating BM25 on many retrieval benchmarks. Not because they didn't do a good job. BM25 is so good. So this is why like just pure embeddings and vector spaces are not going to solve the search problem. You need the traditional term-based retrieval. You need some kind of n-gram-based retrieval.
So for the unrestricted web data, you can't just
you need a combination of all, hybrid.
Yeah.
And you also need other ranking signals outside of the semantic or word-based, which is like page ranks like signals that score domain authority and recency, right?
So you have to put some extra positive weight on the recency,
Correct.
but not so it overwhelms.
And this really depends on the query category.
Yeah.
And that's why search is a lot of domain knowledge involved problem.
Yeah.
That's why we chose to work on it. Like everybody talks about wrappers, competition models. There's insane amount of domain knowledge you need to work on this. And it takes a lot of time to build up towards like a really good index with like really good ranking and all these signals.
So how much of search is a science? How much of it is an art?
I would say it's a good amount of science, but a lot of user-centric thinking baked into it.
So constantly you come up with an issue with a particular set of documents and a particular kinds of questions that users ask, and the system Perplexity doesn't work well for that, and you're like, okay, how can we make it work well for that?
But not in a per query basis.
Right.
You can do that too when you're small, just to like delight users, but it doesn't scale. You're obviously gonna at the scale of like queries you handle as you keep going in a logarithmic dimension. You go from 10,000 queries a day to 100,000 to a million to 10 million. You're going to encounter more mistakes. So you want to identify fixes that address things at a bigger scale.
Hey, you want to find like cases that are representative of a larger set of mistakes.
Correct.